we are going to build a predictive model using supervised machine learning algorithm. Topic for today is predict the percentage score of a student based on the number of hours of dedicated study done by the student in a particular course. We'll be using a simple linear regression model. So here we have used the dataset saved in the CSV format, which has two columns. Hours is the number of hours a person studies in a particular day, and the scores which contribute to the score obtained by a person for studying in a particular duration of time. Now we are going to build a model which can predict the percentage score of a student based on the number of hours a student dedicatedly studies for a particular course. We are going to use the linear regression module to predict the score. Here we'll be using the linear regression with and without using inbuilt libraries. The first step is importing all the necessary libraries, NumPy, Pandas, Matplotlib for plotting any graphs, and then we have loaded the CSV file in the local environment, and after this we have displayed the first 5 tuples of the dataset, followed by which using the tail function we have displayed the last 5 tuples of a dataset, and then we have taken the information about the dataset up in more detail, like the number of non-null values, what is the count and the data type, and this will give the names of the columns, hours and scores. Describe function is used to predict the measures of central tendency, count, standard deviation, and 20th, 25th quartile, 50th quartile for only mathematical values. Then we have used the correlation to find the correlation between hours and scores, and then we have checked does the data set have any null values or not to handle the missing values, and we can see from here that it has no null values. Then we have taken the the hours into a data frame X and then scores in data frame Y, followed by which we have plotted the scatter plot between X and Y variables. This is the plot, and then we have given the labels of X and Y of the scatter plot. You can see that this is the hours versus scores graph, which has the X column has the number of hours of study and the Y column pertains to percentage scores of a student. Then we have imported the necessary libraries for sklearn using the linear regression, which we'll be using for linear regression. Then for analyzing or evaluating a model which we have built, we have even imported the accuracy matrices such as R2 score, mean squared error. We have imported the linear regression module, and from there we have transformed the hours data set, hours column into the particular specified range of -1 to 1. We have fitted the model, and then we have predicted the model using the inbuilt libraries. So you can see that this is the predicted range of values for the given data set. Now we are checking how well a model is working with the predicted value and the actual value. This is the predicted value for the 9 tuple, which is 29.87%, while the actual value in the tuple was 25. We have now found out the intercept of the model build, followed by which we have found out the slope, then mean squared error. Finally, we have found the root mean squared error. Here we have used the train test split module. We have splitted the module in 7:3 ratio, where 70% is allocated to training the data and 30% of the data is tested on the module build. We have plotted the separate graph for both test and train dataset. This is the dataset containing scatter plot containing the train dataset. This is the dataset of the scatter plot containing the test data. We have built the module, and then we have trained the module using the training data set, and we have predicted the module. So now this is the end of the linear regression module using inbuilt libraries. Now what if we don't want to use the inbuilt libraries and want to build it from the scratch? So we'll be looking into this, how we can build it using scratch. First we have found the mean of the X variable, then followed by which we have found out the difference of a particular X value and the mean. We repeat the same for the X, Y values as well. Then after doing all, we can get the data set in this format, that is difference between X. X means difference of Xi minus X bar, and we have squared it even. Then we have found the slope and the intercept. Slope is found out using the summation of xi minus x bar into yi minus y bar divided by xi minus x bar whole square. And similarly, we have found the intercept. Here, we have built a function predicted percentage score. So we have passing this function the hours of study the person does to predict the percentage score. Here, suppose if we input the hours of study as 8, what could be the percentage score of a student? Let's check upon this. If the hours of study is 8 for a day for a person, then the percentage score could be 80% around. Thank you.